Okay, sixth graders, today you're going to be making a model. Please begin by getting your model set up so that you can see all of the different surfaces that were involved in our investigation. Once you have your surfaces drawn, I would like you to draw 3 zoom-ins, one for each of the different surfaces. Mulch, cement, and black asphalt. Using the zoom-ins, I'd like you to draw the surface molecules. Remember, molecules in a solid are found close together. They are moving, but they are just vibrating in place. The sun is the primary source of thermal energy on our planet. And the sun heats our planet through a process known as radiation, where light is traveling as a wave. When that light wave comes into contact with a surface, energy is transferred. Specifically, when radiation or light energy from the sun hits a surface molecule, it will make that molecule bounce or move faster. Molecules that are moving faster have more kinetic energy. More kinetic energy means a warmer surface. We saw in our data that the different surfaces, however, had different temperatures. How could this be if they're all in relatively the same area? Well, the answer is it has to do with how much of the sunlight energy is reflected and how much is absorbed. When more energy is absorbed, less energy is reflected. More absorbed energy means that the molecules in the surface will move faster and thus be warmer. That is also why these surfaces will feel warmer later in the day. They've had more opportunity to get thermal energy from the sun through radiation. So, how does this information help us answer our question? Why is air near the surface warmer than air farther away? Well, the answer is that because air molecules are so far apart, they really are not warmed via radiation. In other words, the sun does not heat our air. Instead, it is the surfaces that heat the air. So that when air molecules are colliding with the surface, thermal energy is transferred. That means those molecules start to move faster. They then hit more molecules, and the thermal energy passes in sort of a domino effect, a lot like what we saw with sound. The further away you get from the surface, the less likely those molecules are to transfer thermal energy to their neighbors. So, just like in sound, energy will dissipate over a distance, and that is why the air molecules farther from the ground are cooler.